So I wanted to talk a little bit more about the parabolas that we talked about in class on Friday. And we first talked about parabolas with the vertex at the origin, and then we let the vertex move around to the point HK, which if we recall when we talked about parabolas that were functions, we used that same notation. So we're trying to make sure we stay consistent with our notation. So a parabola has a geometric definition that says it's a collection of all points that are the same distance from a fixed point F, which is called the focus. So if this is the focus and this is the vertex, then this line has a name that's called the directrix, and it's the line that is the same distance as the focus is from the vertex. That's how far it is from the vertex to the directrix. So we give that distance a name of A, and for every point on the parabola, it turns out that the distance from the focus to the parabola and the parabola to the directrix is exactly the same distance. So we have a new equation for a parabola with the vertex at 0, 0. And this is if the focus is at A, 0, so that means the parabola is opening sideways if the focus is at A, 0. So this is a sideways opening parabola. And if the A is positive, it opens right. So this is A greater than 0. And then if the A is less than 0, it opens to the left. So notice that the y squared is all by itself on one side, and the 4ax quantity is always on the other side. So another important feature about these geometrically defined parabolas is called the focal diameter. And so if you start at the focus point and you say, how wide is this parabola? Well, it's 2a to one side and 2a to the other side. So the total distance here is 4a, and that is called the focal diameter. Focal diameter. So at the focus, focal, the diameter of the parabola is this number 4a, whatever's multiplying the x, if it's opening right and left. So notice you kind of have two styles. You have the opening right and left type, where then the directrix is going to be a vertical line with an equation x equals some number, like x equals 2. Or you can have the same kind of parabolas that we've had in the past that open up and down. So remember, these were a is greater than 0 and a is less than 0, so that part stays consistent. And we had equations of x squared equals y, but now we're going to have any multipliers are going to be on the side with the y. So the squared term is always by itself on one side, and any multipliers are on the other side with the variable that's not squared. So this looks a little different than if we'd written it in function notation. We'd say f of x is 1 over 4a times x squared, but that's not what we're doing anymore. We're using a geometric definition of the parabola. So we looked at some examples. Find the equation of the parabola, then find the 2 points that define the latus rectum, that's this point that goes across the parabola at the focus. It has that special name, latus rectum. So let's look at this one, and I always draw pictures for these, helps orient me. So I have the focus is at 0, 2, so here's the focus, and the vertex is at 0, 0. This distance from focus to vertex is always a. So we can see from our picture that a equals 2. So 4a must be 8. And I can also see that this parabola must open upwards because the focus is always going to be inside the curved part of the parabola. So the distance from focus to vertex and vertex to directrix is always the same. So this is the same amount, a, which is 2. So this is the directrix. So the directrix is the line y equals -2. It's always going to be a line with the equation of a line. So my parabola looks something like this. So I know it's opening upward. And I can see that the x is what needs to be squared, because y equals x squared is kind of my home base parabola that we've learned before. So I know I'm going to have the x is squared. then the 4a comes next, and then the y. So this is the equation of the parabola. Now we need to figure out these 2 points that define the latus rectum, right here and right here. Well, we know that if a is 2 and 4a is 8, we know this distance here is 8. So we know that each way we're going to go 4. So we start at the focus and go 4 to the left, and that's going to get us at the point -4, 2. And then we start at the focus and go 1, 2, 3, 4 to the right, and that's going to give us the point 4, 2. So these are the 2 points that define the latus rectum. Here's our graph, and here's our equation of the parabola. So you need to make a good graph. I don't have grid paper on here at the moment, so I didn't make a good graph, but I want you to make a good graph. So the next one, it tells you where the directrix is. So we know the directrix is the line x equals -1/2, and the vertex is at 0, 0. So again, this distance from directrix to vertex is 1/2. So that's the same distance as it is from the vertex to the focus. So this is 1, and this is 1/2. So I can see that a equals 1/2. So I know that 4a equals 4 times 1/2, which is 2. And I can see that the focus, which needs to be inside the parabola, needs to be inside the curved part of the parabola. So I know the equation now because it's opening to the right, so the a is positive. And I know that x squared equaled something times y was the opening up and down. So this one must be y squared equals 4a, which is 2, times x. So that's the equation of this parabola. And then at the focus, I know how wide the parabola is because it has to be whatever 4a is. So it has to be 2 wide. So I need to go up 1 and down 1 for the total focal diameter to be 2. So I start at the focus and I go up 1. So my coordinates of my point are 1/2, 1. And then I go down 1, so the coordinates of that point are 1/2, -1. So these are the points at the ends of the latus rectum. We graphed the equation and wrote the equation of the parabola. So now we're going to let the vertex move to the point HK. What I want you to notice here is that it's always minus. So it's y minus k and x minus h. X minus h, you're going to move the parabola h units right if you have a minus in there. And now if you have y minus k, you're going to move k units up if you have a minus in there. So remember, we've done this before when we did transformations of graphs, and we talked about how this worked. So now the horizontal and vertical movements are happening in the same sort of way, that if you have minus, it's the opposite of the way you might think it goes. So number 30, we have the vertex is at 4, -2. So I'm going to go 1, 2, 3, 4, -2. So here's my vertex. And my focus is 6, -2. So here's my focus. So I can already see that my distance between vertex and focus is 2, and that's my A. And I can also see that my parabola is going to open towards the right because the focus is always inside the curved part of the parabola. So I know it's going to open to the right. So this is the type here where it opens to the right. So I know it's basically a y squared equals 4ax. That's kind of my home base. And then I worry about the shifts. So I'm going to say y minus the -2 coordinate of the vertex. That's going to be squared. 4 times a is 8. And then it's going to be x minus 4, the x coordinate of the vertex. So I'm going to have y plus 2 quantity squared equals 8 times x minus 4. So this is the equation of the parabola. And now I know at the focus, I need to be 4a wide. This is the focal diameter. So it's a total of 8. So I should go 1, 2, 3, 4 up, and 1, 2, 3, 4 down, so that it's a total of 8 wide. So I can see where the points that define the latest rectum are, just off my graph. It's 1, 2, 3, 4, 5, 6, up 2, so 6, 2, and 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6, so 6, -6. Those are the 2 points that define the latest rectum. And then we have our graph here. So let's look at one more example where we have the vertex is at 3, 0. So here's the vertex, and the focus at 1, 2, 3, -2. Well, the focus being below the vertex tells me this one's going to open downward. So it's y equals x squared is home base for when it opens upward. But since this one opens downward, I know I'm going to have a negative number. So the distance between the vertex and the focus is the a, the size of the a. So I'm going to have x minus the x coordinate of the vertex squared equals, and then this is going to be a negative to make it open downward. And then a is 2, so 4a is 8. Then I'm going to have y minus 0, the y coordinate of the vertex. So you just have x minus 3 quantity squared equals -8y. So then at the focus, we know the focal diameter is 8. So 4a is 8, so it's 8 wide. So we're going to go 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the right to find the points that define the latest rectum. So then I can read them off my graph. -1, -2, and 1, 2, 3, 4, 5, 6, 7, -2. So those are my 2 points that define the latest rectum. Here's my equation and my graph. So for the rest of the section, they're not going to say all those details. They're going to say, analyze the equation. And it means find the vertex, find the focus, and find the directrix, and then graph. So the focal diameter isn't specifically asked for, but you'll need that to draw the graph. So this one, we need to complete the square, so we can write it in this form of x minus h quantity squared equals 4a times y minus k, because we see that the x is squared and the y is not. So let's keep everything with x on one side and everything that doesn't have an x on the other side. And then let's see, we need to take 6 and cut it in half. That's 3. Square that. That's 9. So we need to add 9 to both sides to get a perfect square, which is our goal here, a perfect square like this. So I'm going to have x plus 3 quantity squared equals 4y plus 8. But I want this side to look like some number 4a times the quantity y minus k. So I'm going to just factor out a 4 and say this looks like 4 times y plus 2. So I have x plus 3 quantity squared equals 4 times y plus 2. So analyze the equation means find the vertex. Well, I can just read the vertex right off of this equation. It's -3, -2. So I know where the vertex is. It's at -3, -2. Then I look at this number here, and this number is 4a. So if 4a is 4, then a must be 1. And I see that my equation is basically x squared equals y. That's kind of my home base equation without all the fancy stuff. Well, y equals x squared is the opens up or down. A is positive, so it must open up. And a is 1, so the focus must be 1 away from the vertex upward since we open up. Now we know the focal diameter is 4 wide at the focus. So we go 1, 2 to the right and 1, 2 to the left to get our points that define the latest rectum. And again, that's not being asked for specifically, but it sure makes it easy to draw the graph of the parabola. So we've found the vertex, Now we found the focus is, read off the graph, -3,